So see these questions. So first one, these are all straightforward ones, but you should know how to solve them. Okay. So first one is diazonium formation. So this is the diazonium salt formation. And then CuCl2 Sandmay reaction. Sandmay reaction basically helps in getting this chlorine onto it. So that means the option one is correct here. Next, among the following compounds, increasing order of their density. Just a second. To take it out. If you want to figure out the order of densities, you need to check out how many number of alkyl groups we have. More the alkyl groups, more is the density. Here we have two alkyl and one is more, it will be heavier in mass. So therefore, 4 will be greater than 3, then 2, then 1. Okay, so 1. This will be the correct order. Next, which of the following has highest dipole moment? Dipole moment order varies like this: CH3Cl, then CH3, CH2, Cl2, and CH, Cl3, and CCl4. Okay, so highest would be for this one. When it comes to fluorine only, it is a change. So that is CH2F2 will have more than CH3F, then CHF3, and lastly CF4. So that will be the order. Next, which of the following is a major product? C. CH3 minus will attack on 3-membered and 4-membered ring via SN2 mechanism. So it will attack here, bond will break here. So you will get something like O minus, and you will have two methyl groups here. That O minus will take H plus from here, and that will convert into OH and ethyl. So which is the case 1. Got it? Next. CH3 excess. One CH3 will attack here, the other CH3 will attack here. So that will make HCO minus, CO minus, H, methyl and methyl. That on hydrolysis will give you MECH, Me with OH and OH. Correct? So that is option 2. The simple nucleophilic addition of methyl group, Grignard's reagent. This is the product formation. Next, magnesium in ethanol here. So 2 moles. So first mole will form a Grignard's reagent, which makes it this bond formation with MgBr. This is Grignard's, where we will have plus and minus. And that when you react with the second mole here, like this, the attack would be more on the vinylic side, allylic side here. So that will push here to remove the Br form here. Okay, this attempt is called SN2 prime. So SN2 prime mechanism will be favorable. So you will get this minus attached to this carbon with double bond. So this is the final product which you will get. So that is option 2. Okay. Next, which of the following reactions will give 2-degree alcohols as major? So check out what is the reactions that will happen here. The Grignard's reagent, when you react with O2, this carb anion will connect onto oxygen. So first you will get like this OO minus, and then the second mole will also attempt on it. That is from Grignard's reagent. That will also attack here. Bond will break, and you will get 2 moles of alkoxide. And 2 moles of alkoxide, when you react with H3O plus, you will get tertiary alcohol. Okay, so what are the compounds here? We have methyl, methyl, phenyl. So phenyl, methyl, methyl. So methyl, methyl, and phenyl. That will be methyl, methyl, and phenyl. So what are we getting? We are getting 3-degree alcohol. Now here, first mole will attack here. This bond will be lost. So I will have H, C, double bond O, CH3 plus ETO minus. Second mole, again Grignard's reagent will attack with the second mole. You will get CH3CHO minus CH3, and both of these on hydrolysis will give you one 1-degree alcohol, the other one 2-degree alcohol. So this one is correct. So we are getting 2-degree alcohol. Next, on epoxides, direct attack will take place. Bond will break here. So we'll get PH, C methyl. This carbon is connected to CH2, CH2O minus. And that on hydrolysis will give you 1-degree alcohol. Okay. Lastly, pH, if you attack on this one and open it up, you will get 3-degree alcohol because you will get O minus, pH, and pH. So you're getting 3-degree alcohol. So only one option, the second option is correct here. I hope this question is clear, everybody. 57, how the 2-degree alcohol is formed. Second, whenever you have CH3 MgBr, the attack on the less substitution is more favorable via SN2 mechanism. So that brings you like this with O minus. And that on hydrolysis will give you OH, which is option 3. This is the attack of Grignard's reagent. Next, follow this. MgBr pH minus will attack on NH to remove Cl minus because Cl minus is better leaving group. So we'll get pH NH2 plus Mg Cl and Br. Second case, pH will attack on cyanide and chlorine is better leaving group. So we will get pH PHCN plus Mg Br and Cl. Here pH will attack here and remove the Cl group here. So we'll get CH3, C double bond O, pH. And if you attack one more time, pH MgBr, if you attack one more time, you will get tertiary. Here pH attack here, remove this. One more time when you attack, you will get tertiary. So check out the options matching here. So you can clearly notice that first one is mapping with Q, second one is mapping with P, third one is mapping with 2-methyls and this one, so S, and last one is mapping with R. So QPSR, first one, none. Next, it is difficult to replace chlorine by OH in chlorobenzene for comparison of chloroethane. See what happens in chlorobenzene. So when you have chlorobenzene like this, there is always a partial double bond character on it. So because of this partial double bond character, it is very difficult to break this bond. While when you have CH3, CH2Cl, okay, any nucleophile can attack easily, replace the Cl minus. Correct? So read it again. It is difficult to replace Cl with OH minus in nucleophile comparison to chloroethane, which is true. Fluorine carbon bond in chlorobenzene has a partial double bond character, which is also true and correct reason. So please read it. Finished. The next one. This is the DDT preparation. We have learned this already, that if you have CCl3, C double bond OH with OH plus, that when you react with chlorobenzene, this will attack here. There will be movement like this. You will get CCl3, CHOH, and you will get para position like this. Again, when you attack with H plus, because it is in acidic medium, you will get CCl3, CHOH2 plus chlorobenzene, and second mole of chlorobenzene will again attack from the para position via EA's mechanism. You will get CCl3, CH with two benzene groups with chloro, here also with two benzene group with chloro, right? So what is the product you are having here now? So that is the option 3. This is called DDT. Okay, diphenyl dichloro trichloroethane. Next, aryl halides are less reactive towards nucleophilic substitution reaction as compared to alkyl halides, which is not true. Okay, check out on the aryl halides form. See, like this. Just now I told you about that. If it is an aryl halide compared to an alkyl halide, so nucleophilic substitution will be more easier at this position because it is easy to break. Here it is very difficult to break this bond. So why is that? The formation of less stable carbocation. So there is no carbocation formation here. Double bond character of CX bond, which is the main reason. Correct. Okay. Next, check out. You have MgCl and Cl, right? So obviously this minus can go attack here and remove this Cl group. So what do I get here? So I can have 4-membered ring like this, which is connected with this one. Now you might say, sir, it is at 2 degrees, so why not alkene can come? Yes, you can get minor product as this one and this one. These two are the minor products. You can still get SN2 on a 4-membered ring. 4-membered ring, 5-membered ring, and 6-membered ring can still produce SN2. 3-membered ring cannot produce SN2. Okay. Next. The Woods fatigue reaction involves condensation. What is Woods fatigue? If you have any halobenzene reacting with CH3X or any RX, that will give you halo and alkyl and aryl connection. Okay, so what do we have? 1 mole of alkyl and 1 mole of aryl. Next, what is DDT? DDT is a non-biodegradable pollutant. This is given in NCERT. So this kind of uses you have to read. What are the uses of DDT? Next, what are the names here? When aryl and alkyl gets connected, we just learned that this is Woods fatigue reaction, so which is 2. Next, if you have 2 moles of only aryl, that is called fatigue reaction, so 1. If you get Cu2X2 to react, that is called Sandmeyer's reaction, which is 4. Last one, if you have only iodide getting added and forming NaCl precipitate, that is Finkelstein reaction, which is 3. So 2, 1, 4, 3, which is 1. Clear? Next. Aryl iodides can be prepared by reaction of arenes with iodide in the presence of oxidizing agent. See, aryl iodides means this plus I2 forming iodobenzene plus HI. Correct. But this will be highly reversible reaction. Okay. To make this reaction forward, we require some oxidizing agent so that Hi can be converted into I2. But here the statement is given reverse. That is, I2 is converting into Hi. That is incorrect. In fact, we are converting Hi into I2. So assertion is correct, but reason is false. So please check. Done. Now come to this question. We are reacting with some X here and then hydrolysis that will give you C7H35OH. H15OH. Check out. We have 1, 2, 3, 4. Okay. 5, 6, 7. 1, 2, 3. 1, 2, 3. 1, 2, 3. But problem I'll tell you. This C minus will instead make first acid base reaction. It will take H plus. Same way here also it will take H plus. Here also it will take H plus. So these three will never make a reaction of substitution. Only acid base reaction will take place. Therefore, the better attempt is like this. If you have this minus and MgBr plus, this minus will attack here, bond will open up here, and you will get this as C7H15OH, which is option 3. Chloroform must be kept in dark bottles up to the brim. Yes. Why? Because chloroform CHCl3 plus O2 in light will immediately convert into CoCl2 plus HCl. And phosgene gas is a very poisonous gas. In sunlight and air, chloroform might explode because of the formation of peroxide. No, it is not forming any peroxide. Correct. It is only forming phosgene gas. So one is true, second statement is false. Okay. Next, which of the following reaction leads to the formation of chloritol? Okay. What is chloritol? See, if you have an acetone plus chloroform in the presence of OH minus. So OH minus will take H plus from here. So that CCl minus will go attack here. We will get this as O minus, CCl3 getting attached, and then adding with water, you will get OH and CCl3. This is a product. This is called chloritol. So this is the one which is used as chloritol. Okay. Chloritol is a hypnotic drug. Hypnotic drug, correct, and also used as local anesthesia. Clear? Right. See the next one. We need to find out how many number of X moles of CH3 MgBr are used. You know that when there is an ester, it will attack 2 moles. RMgX will attack 2 times here till it becomes alcohol. One RMgX can consume H plus from here. Another RMgX can consume H plus from here. And this will become O minus, S minus, and here you will get alcohol. And that on hydrolysis will again bring back the H plus. But how many moles were overall consumed? X is 4 moles. So 4 moles of RMgX are consumed. Clear? Next. Number of RMgX required for the complete reaction as X, Y, and Z. Okay. So what is X plus Y plus Z? So here you know that 2 moles are required for esters. Acid chloride 2 moles are required. Here 1 mole is required for taking H plus. 2 moles are required for ester. So 1 and 1. So total how many? 7 moles in total. Got it? Next, how many of them give positive iodoform test? So you can see what is the first thing we need to search. For alcohols, we need to check at least one hydrogen should be present, and adjacent to that there should be methyl. So this qualifies. For aldehydes and ketones, only methyl group we need to check. Also methyl is there, qualifies. Here also hydrogen is there, methyl is there, qualifies. Active methylene always qualifies. Here there is no methyl group. So how many? 1, 2, 3, 4, 5. So 5 of them will give iodoform test. Next. How many chlorines are present in chloropicrin? So what is chloropicrin? If we have chloroform reacting with concentrated HNO3, that will convert into CNO2 and 3 chlorines on it. So this is called chloropicrin. So how many chlorines do we have? 3 chlorines in it. Okay. Freon 1, 2. Okay, what is Freon 1, 2? Freon 1, 2 means there is 1 carbon and 2 fluorines. Rest will be chlorides. Correct. So how many chlorides are there here? 2. Gamaxine. Gamaxine, if you remember, is addition of all chlorines on it, on benzene. That makes it gamaxine. So how many chlorines on it? 6. Got it? So how many do we have? 11. Done. Next. How many geometrical isomers are possible here? See, first this will go and attach here 1 mole, and 1 mole will take H plus from here. Right? So what is the product I will have? Right. So first you will have excess of this being used this way with, we have OH here and propyl here 1, 2, 3, and here we have OH. Okay, this is after here, after the addition of H plus, this is the product which you will get. Then on protonation and hydrolysis you will get an uh, alkene like this. So an alkene will be formed here and alkene will be formed here. This side also we can have cis and trans isomers. This side also we can have cis and trans isomers. So total there are 4 geometrical isomers. So please note, please check.